Hello everyone. Here I am going to explain the task chart with PDF using RAG pipeline. The main overview of this whole task is to implement a retrieval augmented generation pipeline that allows users to interact with the semi-structured data in multiple PDF files. The system should extract chunks, embed, and store the data for efficient retrieval. It will answer users' queries and perform comparisons accurately, leveraging the selected LLM model for generating the responses. Let's go into the code. Here the commands we use pip install pipedf to pip install transformers, pip install OpenAI. Let's know more about this. And pip install pipedf installs the pipedf2 library, which is a Python library used for working with PDF files, and it provides the functionalities like reading, extracting text, splitting, and merging PDF documents. And next, pip install transformers. Install the transformers libraries developed by Hugging Face. And the purpose of pip install transformers are enables working with state-of-the-art natural language processing models such as GPT, BERT, and T5. And key features of PAP install transformers are provides pre-trained model for tasks like text classification, translation, summarization, and more. And it simplifies the process of tokenizing text, creating embeddings, and generating text. Next, PAP install OpenAI. Installs the OpenAI library, which is the official Python SDK for interacting with OpenAI's API. And the main purpose of PAP install OpenAI is enables the integration with OpenAI's language and image generation model. And it simplifies the API request to generate text embeddings or images, and also it handles API authentication and communication. Next, here the code. Here are the some imports: OS, OpenAI, PyPDF to NumPy, and let's know more about imports. OS is used to provides the access to operating system functionality like environment variables, and OpenAI for using the OpenAI's API, like example generating embeddings or text. And then PyPDF2, it is a library used to read and extract text from PDF files. And then transformers, this can be auto tokenizers, auto model for casual LM, like auto tokenizers used for tokenizes the input text for NLP model, and auto model loads pre-trained model for embeddings. And then NumPy provides numerical computing capabilities such as cosine similarities. Then API key from environmental variable, it can fetches the OpenAI API key from the environment variable like Open API key. And then model name, this can be used to sets the embedding model to all mini LM L6v6, and it initializes the tokenizer and model for sentence embedding, and then ensures pad token if set if not already. Then it ensures the tokenizer has a padding token using the end of the sequence, EOS, we call it as EOS token if non exists. Then generating sentence embeddings, it tokenizes the input text, truncates long input, and add padding to make sequence uniform. Then and it also passes the tokenized text through the model to generate embeddings. And the embeddings by averaging the last hidden state, this line explains about the averages the last hidden state for all tokens to create a single embedding vector for the text. And it also converts the tensors to a numpy array and flatten it into a 1D array. And then next function is chunk store. It initializes a store text chunks and their metadata. Example like embeddings and source. And then PDF text extraction. This function explains read a PDF file and extract text from each page. Append non-empty text to a list and returns all the things. That means or adds all the text from the non-empty chunks. And then the function to chunks text into smaller parts. It can be explained this splits the input text into chunks of approximately 500 words for easier processing. And then for each chunks it can generate an embedding using encode text, and it stores the embedding original text and metadata in the chunk store. And retrieving relevant chunks, this function encodes the query into an embeddings, and it calculates the cosine similarities between the query embeddings and each stored chunks embeddings. And this function uses the sorts chunks by similarity and returns the top k most element, like either in descending order or ascending order. Then response generation, here loads the gp2 model and tokenizer for text generation, and it prepares a context string using the retrieved chunks and appends the user query. It prepares the context string from the user query. Then it tokenizes the prompt and ensures it fits with the model token limit. And it generates a response using nucleus sampling for diversity and randomness. And then processing a PDF. It specifies the PDF file path and initializes an empty list for chunks. And it initializes the empty list for the chunks. And then it extract text from the PDF and chunks it into a smaller parts and store embeddings in the list. It stores embeddings along with the metadata like source file information. It gets the whole information from the PDF. And here are the some example queries, and it processes the query like questions what is cloud computing, and retrieves the relevant chunks and generate the responses. It gets the information from this PDF and it get responses. And the next query is various types of cloud computing. Same, it gets the response from the PDF, and here is the output. And here is the some query questions what is cloud computing and various types of cloud computing. The answer what is cloud computing was get from the PDF it was generated. Thank you.